next example here talks about a three-step equation. And a lot of times in an algebra class, when the teacher gets the class to do three-step equations, he or she feels really satisfied because that's quite a significant milestone. So we have a complicated looking expression up here in terms of our balance. And let's go ahead right away and write that in terms of the algebra textbook. We've got 4 boxes in 1, so that'll be our 4b plus 1, balanced by, on the right-hand side, 2 unknowns, or 2 boxes, and 11. And this is no more complicated than what we've seen before, just using examples 1 and 2, removing things from each side of the balance beam, removing things from each side of the equation. So we'll go ahead and start here, and since we only have a single one on this side, that's an easy thing to remedy, and I'll just say get rid of that and get rid of that, which is the equivalent, of course, over here of subtracting 1 on both sides. And we'll put in our balance line here, which we've been using a blue dash line, but any color works. And then let's take a look at the algebra over here. On the left-hand side, the good news is now we only have the unknown, 4 b's. On the right-hand side, we've still got 2b plus 10, so we still have some unknowns and some constants, but that shouldn't throw us too much because now we have something that is quite a bit simpler than this. And that's reflected over here because we end up with a simpler picture. On the left-hand side, that's gone. So all we have here is 1, 2, 3, 4 boxes. On the right-hand side, 1, 2, and 1, 2, 3, 4, 5, all the way up to 10. Well, the constants are all on the right-hand side right now. So the typical way that an algebra book or an instructor suggests this is get your constants on one side and get the unknowns on the other. And the easiest thing to do here is to say we've got two boxes here and 4 over here. Let's get rid of an equal number of boxes on each side. So we'll pull off 2 boxes from each side, still being the balance. And so what that means here is minus 2b and minus 2b over here. And on the left-hand side, that gives us 2 boxes remaining, balanced on the right-hand side with what we have left. And what we're looking at here is, again, 2 things that are opposites, or additive inverses. And 2b minus 2b gives you, again, 0. So the only thing remaining here is 10. And the picture over here is going to say, very simply, a pair of boxes and our 10 on the other side. And now we're getting ready for our last step, which is to go from 2 boxes to 1. Well, we have twice as much as what we need. So the obvious thing is to divide that in half, or cut it in 2 equal parts. And to cut it in 2 equal parts, mathematically, symbolically, you're just dividing by 2. So we want to make sure, of course, that we're doing it in both sides. 10 divided by 2 turns out, of course, to be 5. On the left-hand side, we're going to introduce or reinforce one other topic, and that is any quantity divided by itself, any number divided by itself is equal to 1. And so what you can do to reinforce this is just to take the 2 over 2 and draw a large number 1. And this one looks a little bit slanted, but that's okay. You still see it as a 1. And so the only thing that's left there is 1b, or just b. And if we model that over here, we're dividing things in half, dividing by 2, so we can go very simply like this. And when you look at that visually, the answer just pops out at you, because each box is matched up with 5. And so to finish up the physical model here, we're going to say we have a balance between 1 box on the left and 1, 2, 3, 4, 5 on the right. So the original problem that we have here up on the top looks fairly complicated, either algebraically or physically, manipulatively here. But just by using some very simple operations here involving the balance line and additive inverses and numbers being divided by themselves, you come down to where the box or b is equal to 5.